Hi, I'm Miss McTaggart and this is lesson number 5 in the topic of circles at higher maths. In this one we're going to prove tangency. We're going to prove that things are tangent, lines are tangents to a circle, or maybe that they're not tangents. Again, this is something you've possibly seen already when you've been doing quadratics and proving something is a tangent to a curve, so it is pretty similar. So if a line is a tangent to a curve, then we're looking for exactly one point of contact, or repeated roots, okay? Repeated roots means you've got the same bracket when you factorise, like x plus 1, x plus 1. You can also use a discriminant after the substitution method. Now, this is actually probably going to be more common to use the discriminant is if you're proving it's not a tangent, right? So we use that when it's proof of not being a tangent. Alright, because what happens is if you're going to do all the discriminant work to prove it's a tangent, you still have to go back and factorise to get the points of contact because that's what they're normally looking for. So we like the method where we do y equal to y again, but we'll go for its substitution in this case. We're going to come out with hopefully a repeated bracket which shows it's a tangent, and then that gives us our x value to get the point of contact. Alright, but if it's not asking you to prove it's not a tangent, we're going to do the discriminant because you'll get to a thing that doesn't factorise anyway. Best way to illustrate this is let's do some examples. Okay, and obviously a quick reminder of discriminant, easier for these scenarios. When it's less than 0, you've got no point of contact, so it's not a tangent. If it's greater than 0, that means you've got 2 points of intersection, which is what we're kind of doing when we're finding the 2 points of intersection. And then the one where you have to prove it's a tangent, you're looking for equal to 0. But as I said, for this one, we tend to just do it by factorising and getting that repeated root sentence in. So example 1, prove that this line is a tangent to this circle. So wherever I see y, I'm going to replace it with this in a bracket, okay? So let's get started. This is the one that fills your whole page to start off with. So x squared plus x minus 10 all squared plus 4x plus 8 bracket x minus 10 all squared. And then I have a minus 12 equals 0. Let's expand this out. So x squared plus x squared. Take away 10x twice, so take away 20x plus 100 plus 4x times the bracket out, 8x minus 80. Oh, I've made a wee mistake. I've put a squared in there. That shouldn't be there. Sorry. 8x minus 80 minus 12 equals 0. There we go. Really messy. It's really hard for me to fit this in. I'd be a lot neater if I was doing it on a page. Right, tidy up. X squared plus x squared. So I've got a 2x squared. My x's. If you find tidying up difficult, do what I'm doing and underline the ones that you're tidying up so you don't miss any. So I've got minus 20 plus 4 plus 12. So that's minus 20. I said the wrong thing. I'm thinking ahead again. 4 and 8 is 12. So minus 20 plus 12 gives me minus 8x. And then my numbers, I've got 100, take away 80 and 12. So that's 100 take away 92. So I have got plus 8 equals 0. I spy a common factor here of 2, making it much easier to factorise. So x squared minus 4x plus 4 equals 0. This factorises, this is what we're looking for, okay? This factorises into like matching brackets because you get x minus 2. X minus 2, alright? And then if you solve that, you get x equals 2 repeated. Okay? Now this is a sentence. This is one of these must-write moments. So you write repeated roots. So 1 point of contact. Therefore, line is a tangent at, now this is a bit I didn't do, they wanted the point of contact, so you got a repeated root of 2, so you know it's at 2 something. To get that other number, you go back up to this bit here and plug in the number 2. So you're going to do 2 take away 10, which is minus 8, so your point of contact is at 2 minus 8. You must write the sentence, you must find the point of contact. So if it's a prove it's a tangent, we like this method because the x equals 2 comes out naturally. Alright? Example 2. Prove that this line is a tangent to this circle and find the point of contact. So we're going to do the same again. Wherever I see y, we're going to plug in the 3x plus 10. So let's go. So x squared plus 3x plus 10 all squared. Take away 8x. Take away 4 times our bracket. Why is this 4 not wanting to go? 3x minus 10 plus 10 even, saying the wrong thing. And what else have I got? I've got minus 20 equals 0. Please watch, you don't skip a term. It's really easy to maybe skip that term or that term when you get carried away with the bracket work. Okay, x squared. Expand this bracket. Again, remember you can go to the side and do this if you're not brilliant, or you can take some extra lines of work in. 3x all squared would give you 9x squared. You'd have 3x times 10 twice, so double 30 is 60x. Bigger numbers than this one. Plus 100. Then you've got that 8x there. Right, we're timesing it by minus 4, so minus 12x, minus 40, minus 20 equals 0. Tidy up, 10x squared. Our x's, we have 60, sorry, minus 8 minus 12. So that's just 60 take away 20, giving us 40x. And then the numbers, you've got 100 take away 40 take away 20, which is 100 take away 60, so 40 equals 0. Again, look, we've got this common factor, let's take that out, giving us x squared plus 4x plus 4. Right, not the best examples, I've come out the same thing again, I've come out the same trinomial to work on. But just to prove, what you could do at this point is you could go do the discriminant, you're giving yourself extra work in though, but you could go do the discriminant and say, right, let's do b squared minus 4ac on this trinomial. You would have 16 minus 4 times 1 times 4, which gives you 0. And you would say b squared minus 4ac equals 0. So 1 repeated root, or even, so repeated roots imply a tangent. However, you still need to go at the blooming point of contact, so you're going to have to go back and factorise this thing anyway. So we need to go back and factorise and get x plus 2 equal to 0. So x equals negative 2 repeated. So the point of contact is when x equals 2. So we take 2 and then we plug that into the straight line, which was 3x plus 10. 3 times 2 is 6 plus 10 is 16. Now, essentially, you don't really need to do that blue bit with the discriminant. You could just factorise down and write the sentence as example before and say, repeated root, one point of contact, line is a tangent. Alright? And then you get the point of contact as well. So for me, what I've just done there with that blue pen is really not necessary, but it is an option. Now my third example says, show that this line does not intersect, so show that it's not a tangent, okay? So, and I've used this other circle formula as well, just to give a wee bit of variety. So, we do the same. Wherever I see y, I replace it with the 2x plus 2. Right, so we have x minus 5 all squared plus 2x plus 2 plus 7 all squared equals 56. Write this out again, x minus 5 all squared plus, right, so that 2x plus 2 plus 7 gives me 2x plus 9 to actually square out. Must tidy that up first, okay? Okay, so if we expand those brackets, if you're unable to expand these in one go, you go put in the extra lines of work and write the brackets out twice. But this will give us x squared minus 5x, so minus 10x plus 25. Then it will give us plus 4x squared plus 18 plus 18, so plus 36x plus 81 equals 56. Let's tidy this up. So we have 5x squared. We have minus 10 plus 36, which is plus 26x. And then 25 plus 81. I'm just going to subtract that 56 at the same time, and that'll give me plus 50 equals 0. Now, a quick glance, this isn't going to factorise. A lot of times when they do factorise, there's a common factor here. So we have to go to the discriminant to prove that it does not intersect. So we're going to do b squared minus 4ac, which will be 26 squared minus 4 times 5 times 50. And then that will give us, which is 676. Take away 20 times 50. So take away 1,000. So that is negative 324. So because our discriminant, b squared minus 4ac, is less than 0, normally we would say there's no roots, but in this case there's no point of contact. So the line is not a tangent. Oh, sorry, the line does not intersect. I was going to say line does not meet the circle because that will fit in better. Okay, and that concludes the videos. Hopefully I've shown you all the scenarios you need to do. Thanks for watching.